Okay, so we're going to learn the unit circle, and this is going to be the basis for pretty much everything else we're doing this year. And a lot of things that you'll do next year in either pre-calc or trig, and a lot of applications in calculus. So we're going to start. We know that the radius is 1. Okay, we're going to use that in a little bit. The first thing I'm going to teach you is about degrees. So for the degrees, it starts at 0, and we're actually just going to put all the degrees we know on here. So we know this is 0. We know this is what angle? 90. Oh, yeah, so you can pick one color for the degrees. We're going to do another color for the radians. This would be 180. Do we remember this one? Choose 70, great. And then one full time around is 360, and we do put that on this circle as well. So the most important part of the unit circle for us is the first quadrant, because everything stems from the first quadrant. So I'm going to show you guys how to use these angular rulers today. At the bottom, they have the scale, which is your angle. So we were talking about 30, 60, 90 degree triangles before we started this, because the first angles on your on this are going to be 30, 60, and 45. So these are the angles that we're going to be making today. What? I don't know. Okay, so once you have the 30 degrees, we're going to go like this. Okay, we're going to line it up here. So it says 30. Okay, and then we're going to put it in the center. Okay, so then you're going to draw this. The center will be in the center of your circle. Okay, some of you have a protractor, and with the protractor, you're going to split the 30 degree angle. Okay, if you have a protractor, okay, it's very similar. You are just going to put this at the center, and then you mark off the 30. Can you see where mine is? You just make a little mark here, and then you're going to connect that. Okay, so then I want you to just write 30 degrees here. Okay, the next one we're going to do is 45. I'll show you guys how to do it with the protractor first. So the protractor, if you do 45, it's right in between 40 and 50. You just make a little mark there. Okay, and then you're going to draw from the center to your edge that goes through that mark. Okay, so that's your 45 degree. If you have this, you're going to go to 45, and then just like we did before, we're going to center that, and we're going to make that angle. And then after that, which one are we going to make? Yeah, great. I know, thanks for bearing with my voice today. Like I said, I feel fine. I sound terrible. This is 60 degrees. So I'm going to use my second color. Okay, when you're doing your radian values, remember that we used this conversion of pi over 180 because pi over 180 is equivalent. It's the same thing as 2 pi over what? 360. Okay, now all the radians here that we're going to talk about are based on fractions of this circle. Okay, so if you multiply 30 degrees, and you don't have to do this on your paper, I just want you to look at this with me. 30 degrees over 180. What is this ratio, this fraction? 1/6, okay? So it's 1/6 of pi. 1/6 of pi is what we call pi over 6. That's why at 30 degrees, you have pi over 6. If you want to write these so that they're facing you, I think that's a little bit easier than to write them slanted because we are going to go around the circle. If you're watching the video, you won't be able to see this, but I just want to show you that what this means is if you were to split this is 1/6 of this top half here, okay? So this would be 6 pieces of 30 degrees. That's why it's pi over 6. Okay, so for 45 degrees, do you remember what the radians are? Pi over 4. So if you look at this part, right, if I split this into 4 pieces, see how this is 1/4 of that top? That's where it comes from. Okay, it's just a fraction of what you have. Do we remember what 60 is? Pi over 3. Good. Okay, and then this is still 0. Okay, and then 90 degrees is pi over 2 because it's half of it. So pi over 2. Excellent. Okay, and we know that this one is going to be pi. All right, so so what we're going to do from here is we're going to extend the angles that we made using our straight edge. Okay, and then what I want you to do is I want you to just extend each one of these with your pencil. And I want you to come up with a way to find what these degrees are based on what you know about those angles. Okay, and we're going to talk about how we found them. And if you're too scared to write it down, that's okay, but I want you to talk about it with your row. Okay, so we extended them, which was a straight line, right? And a straight line is what? Okay, so remember, it's this angle that's 30 degrees. So if I want to find what this angle is, what could I do to 30 to find it? Add 180. So let's do that. So if I add 180 to 30, what do I get? 210. Great. And I could do that for every single one. I could add 180 to 45. I could add 180 to 60. Is there something else that you guys were thinking you could use once you have it? Yeah, so the distance between these is 15 degrees, right? So 30 to 45, 45 to 60. So let's just add 15. That'll make it a little easier, I think. Okay. Now for the radians, you can do the same thing where you add pi. If you're adding pi to pi over 3, what are you adding to this? Okay, so what is pi plus pi over 3? So 4 pi over 3, right? You add pi, okay? I'm gonna show you another way to fill in the pi's as well. So we will just hold on to that for right now. Okay, the next thing I want you to do is in quadrant 2, we have to have the same pattern. So we're going to take the 30 degrees, we're going to make the 30-degree angle here. So this is the reflection of those. And then do the same thing with the 45 degrees. And do the same thing with the 60 degrees. And then we're going to label it. Sorry, I don't have enough for everybody. Probably somebody took on the Christmas tree. Never brought it back. What was it? Okay, so how do we want to find what those angles are? So from 60 to 90 is how many degrees? 60 to 90. Oh, 30. So I could do 90 plus 30, and that would be 120. And then what's the distance in degrees from here to here? 15. Yep. And then 15 again. And then we are going to do the same thing where we want to extend them into quadrant 4. And again, please label your degrees for those. It's okay if they aren't perfect. Alright, so we should be finishing up our degrees now. We know that there's always a 30-degree difference here, and then a 15-degree, 15-degree, 30. And that pattern continues all the way around. 30, 15, 15, 30. 30, 15, 15, 30. 30, 15, 15, 30. So on and so forth. Okay, when you are doing the unit circle, the only thing that you are going to memorize is going to be this first quadrant, this 0, 30, 45, 60, 90, the 0, pi over 6, pi over 4, pi over 3, pi over 2. Everything else can be generated by counting. So I'm going to give you guys a couple seconds just to finish off. I want everybody to be ready to count the radians. I think a couple of us are just finishing putting those degrees on there. Okay, so the first thing we're going to do is we're going to count by pi over 2's. So pi over 2 is 90 degrees. So if I do 1 pi over 2, I'm at 90. If I do 2 pi over 2, where do I go? Pi. This isn't 2 pi over 2, just pi. Okay, so the next thing I'm going to do is go to 3 pi over 2, which is at 270. And what is 4 pi over 2 reduced to? 2 pi, which is here. Okay, the next thing we're going to do is we're going to count by 45 degrees. I'm going to show you this on the smartboard. So you have, this is 45 degrees, okay? That's at 1 pi over 4. There's 2 pi over 4 in degrees. 90, there's 3 pi over 4. So keep counting by 45. 135. So this is 3 pi over 4. This is 4 pi over 4. I'm going to keep going 45. 5 pi over 4. 6 pi over 4. 7 pi over 4. 8 pi over 4. So see how I'm going 45 degrees each time? They're the same distance away. But anything that can be reduced is being reduced. Okay, they're the same distance away on the unit circle. So what we're going to do is we're going to fill in the ones that don't have radians. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 reduces to pi. Do you guys remember what 5 pi over 4 is? 225. 6 pi over 4, 6 fourths reduces to 3 over 2. 7 pi over 4 is right here. Now take a second and look at some of the relationships here. I have pi over 4 here. If I follow this line, do you see how the denominator is a 4 again? And then it also happens here. Okay? And remember we talked about how we could just add pi. So pi over 4 plus pi is 5 pi over 4. 3 pi over 4 plus pi is 7 pi over 4. Okay? Alright, now we're going to do pi over 3. So pi over 3 is how many degrees? 60. So this is 1 pi over 3, and I'm going to keep going 60 degrees. So this is 2 pi over 3. This is 3 pi over 3. This is 4 pi over 3, 5 pi over 3, and then 2 pi is 6 pi over 3. So can you guys see how these are all the same distance apart? Can you see them all together? They're all the 60 degrees. So now we're going to write those down on our unit circle. So the 2 pi over 3 would be right here. Just the 3 pi over 3. Okay, here's your 4 pi over 3. Okay, you have your 5 pi over 3. And again, if you follow those lines, okay, if you're on the same line, the denominators should be the same. You can also think of them as reflections. See how this line would be reflected here? This line would be reflected here. This line's a reflection. This line's a reflection. Alright, so now we're going to use pi over 6 to help us fill this in. But pi over 6 is 30 degrees, so it's going to hit a lot of points that we've already done. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So let's fill that in. We have 6 pi over 6, 7 pi over 6. So we're going to fill that one in. 8 pi over 6 reduces, 9 pi over 6 reduces, 10 pi over 6 reduces, 11 pi over 6 is the next one, and 12 pi over 6 is 2 pi. Okay, so those are the degrees and those are the radians. Now, one of the most important parts are the points that are on the unit circle. So we're going to use the fact that the radius is 1. And if the radius is 1, can you guys tell me what this point would be on an XY plane if the radius is 1? Not 1, 1, but this would be 0, 0. This would be 1, 0. Yeah. What would this point be? 0, 1, yeah. What would this point be on an XY plane? Negative 1, 0. Good. And this one would be awesome. Okay, now every single place has a point. Okay, you don't have to write this part down, but I just want to show you how we are going to find these points. So earlier today, we took a triangle that had a radius of what? 1. And didn't we say the unit circle's radius was 1? And the radius is defined as the center to a point on the outside, right? So this radius is 1. If I want to find this point, which is an XY point, I have to find this is my X, this is my Y, and remember, this angle that I measured and you measured was what? 30 degrees. So if this is 30 degrees, I can use my 30, 60, 90 rules, right? So if this is 1, what do I know Y is? 1 half. Yeah. And what is my X going to be? Guys remember? Square root of 3 over 2. Okay, so that is your point. Okay, on your unit circle. Okay, this is root 3 over 2. 1 half. That is your X and that is your Y. Now we have this 45, 45 triangle. Again, the points are X and Y. Okay, if you flip it over, you can remember what are your X and Y values for a 45, 45. The radius is 1. Let's look, flip it over. What were they? Root 2 over 2 and root 2 over 2. Okay, so that's what we're going to put there. And then you guys remember what the last one was? Your X and your Y? Remember, it was the same thing as this. It was just what? Flipped. Okay, so like we said, this is the only part you're going to have to memorize. So let's start to look at some similarities. Okay, so what's one thing you notice about all your points? Yeah, they all have 2 as a denominator, okay? Ready to see something cool? This is root 3. Not ready? Okay, let's take them. Ready? Okay, this is root 3, this is root 2, and this is root 1. Isn't the square root of 1 1? Okay, so as long as you know that the denominator is 2, you can use this point. What's the square root of 0? 0. So this is root 0, which is 0. This would be root 1, root 2, root 3. Just have to simplify it if you can. So 0, 1, root 2, root 3. Root 0, root 1, root 2, root 3. And then the other way, yep, goes the opposite. So root 0, root 1, root 2, root 3. Okay. All right, now everything else is going to stem from this pattern. So in quadrant 1, the signs of x and y are both what? Positive. You have a positive x. Yep, last color. So you have a positive x and a positive y. In quadrant 2, you have a negative x and a positive y. In quadrant 3, what do you have? Negative y. And in quadrant 4, positive x, negative y. So everything is a reflection. So what we're going to do is we are going to reflect those points. I'm going to show you a couple and then I'll have to finish it. Okay, so if you reflect this point to quadrant 2, you reflect this point, what's the degree where it becomes reflected? That's 120. This is the reflection, right? Okay, so then it's the same point. I'll color code it. So this point is reflected here, right? And then in quadrant 3, where would this be reflected over your x-axis?
That's not one.
No. And then, this would be reflected here. Okay, so if you reflect that point, this is the same thing, except you have negative 1/2 positive root 3 over 2. In this quadrant, you have negative 1/2 negative root 3 over 2. In this one, you have positive 1/2 negative root 3 over 2. Okay, do you guys think that you could do that with the rest of them? Okay, so this cuteness featured here. Okay, so those are your reflections. Okay? And if you're watching the video, I'm sorry, but you don't get to see the cool colored map. Alright, so the reason why you need to have those points there is because, remember we've been studying sine, cosine, and tangent? Do any of you know what is what on the axis? Every point is cosine of theta, comma, sine of theta. Okay, which means your x value of every point, your x coordinate is cosine, your y coordinate is sine. Does that have what? No. Okay, well that's cosine and sine, but we can't forget about our man at the beach, our tangent. The tangent is sine divided by cosine. Okay, which is the y divided by your x. which is what we're going to talk about a little bit more tomorrow. Okay, so the only thing, well, there's two things you have to finish. So you need to finish filling in all of your points on your unit circle. We'll check that tomorrow, and you have to turn it in on Google Classroom. Okay, along with, you have to finish this part of your special triangles worksheet if you have not already. Okay, so you need to turn both sides of that into Google Classroom.